Welcome back, everybody, to Ask Why, where we take engineering challenges and problems and break them down in simple ways. Today, we're going to talk about AI and magnetics. So AI is slowly transforming every industry: data centers, cars, factories, even homes. But behind the intelligence lies a lot of power, delivery, and signal integrity. And that is where magnetics make a big difference. Today with me here, I got Patrik and Yossuf, associate directors for our magnetics unit, and we're going to dive in together and look it down what AI and magnetics, how those two actually play together. So let's go ahead and start with the core of it. So let's start with the heart of AI, data centers. What's happening in the servers, high performance, computing, how does all of that impact magnetic design?
So basically, we are seeing like a type of shift from 12 volt to 48 volt, and now also up to 400 volt high volt DC, right? So for that, of course, you need like a very robust components to deal with, right? So we from the magnetics, we have of course the components, not only like the transformers, but also the inductors, and also all the type of wireless, and also for the noise for the AMI. Those type of products which can be used for that to meet, of course, the high efficiency, not only for that, but also the low loss inductors in the transformers, which are still needed for those type of high requirements what we are seeing on this application.
YAGEO being the point of where you get whatever you need, we have some good news for AI and servers in particular, where in fact, Yossuf talked about the inductors, and there is a whole set of different possibilities. It's depending also on the wallet size that you will have or on the budget. But let's say for the high-end type, we have our latest, newest material that is extremely high in performance. It's called the nanomet. It's used for kind of TLVR inductors. But then we have also the ones in the middle, which is just a plain TLVR type with ferrite material, which is also very still acceptable in terms of performance. And then really when you need to have the lower end type of plenty of inductors, small type bead inductors, we can cover this as well. And Yossuf was also talking about the 48 volts down to 12 volts. So we talk about AC optimization, we talk about DC optimization, and we can help always to find the right product for which type of optimization you want to work on. For DMI, the power output and these kind of aspects, but maybe let's keep that for a few minutes later. I might come back to that again.
Hey, that's no problem. Now, when I start looking at AI, just this morning I drove in a vehicle that actually had AI integrated where you could just use it right there in your car. So it's not just on our computers anymore. It's in our cars and really getting integrated into everything. So how does that play a role when we start looking at autonomous vehicles in the future with AI integration in vehicles and magnetics?
Yeah, basically for that, I mean, for the AI processors, for the ADAS, also for the autonomous driving, it requires mass of data, right? Also clean and also low noise support, right? So that means we have not only for the EMI, but also for the magnetics overall, we have, let's say, a bunch of products which can be like solve this type of issues when it comes to the frequency noises, right? Or to the signal noises in this case. So when we're talking about the ADAS or the autonomous driving, so it's not only the communication itself, but it's also the vehicle-to-vehicle communication. So for that, you probably need like the antennas, right? Specifically for the cars, and then there's also standards what you have to follow. It's not only the ACQ 200, it's also like safety standards what we have to follow and going through, but also due to the fact that in the automotive itself, we started with a CAN, right? And then we had the broader reach, the automotive Ethernet, and now moving to the zonal architecture. So there's also like a shift inside of the overall automotive topology when it comes to the communication. So we have the magnetics, as mentioned, the inductors, the signal common mode chokes, for example, for multi-gig Ethernet. And then also, of course, when it comes to the AMI, I think Patrik has some.
Yes, like you said, your products are all, of course, ACQ 200, right. And this request is also coming for the chokes for the power line side. And normally, in general, you would be restricted to have at least 150 degrees Celsius. So everyone is using nanocrystal type of chokes on the market. But we have also some choice to offer because we do our own ferrite material, and we have currently newly a ferrite material that is able to achieve 150 degrees Celsius. So this gives us the possibility to play with different possibilities, also playing on the cost side by having all these products possibilities at ACQ 200 type of level. And on the radiated side, we have our EMI cores and the flex suppressor that I might talk a bit later again afterwards. These are also ACQ 200 without in fact being requested or required to be that. We just do that so that we can give PPAPs and the level 3 documentation and all these kind of services for the automotive customers.
Now, Yossuf, you talked about connectivity already. So obviously AI thrives on connectivity. So what role do magnetics play in that area?
Of course, we have, specifically when it comes to the magnetics, they have inductors here in this case for the high frequency communication. But also there's a, when we're talking about signal magnetics, so we can also talk about the PoE, like the Power over Ethernet edge, or let's say to powering the Ethernet through the edge devices, right? So, which is also pretty much needed for the AI in this case. Isolation is also one of the topics which is still probably always needed here in this case, when we are talking also for the connectivity itself. So we have the Ethernet transformer, the isolation between the communication, and then also probably for the EMI, also Patrik, which is probably maybe also giving something for that.
Right, so we have that flex suppressor I was talking about before for solving EMI issues, but here in somehow it's going to be different because here we talk about wireless communication. So in fact, we don't want to destroy a magnetic flux. We want to make sure that magnetic flux is able to, in this case, maybe not charge, but to transmit some data. The further, the better. And in fact, our flex suppressor, even if it's in super high frequency range, we are able to help up to 3 times improving the communication distance.
Now, of course, using AI to improve the environment is always a big thing. Now we start integrating into smart factories and we have automation happening everywhere. AI is being integrated. But of course, if we don't pay attention to our magnetics, I think we can actually design ourselves in a very inefficient product. So how do we actually use magnetics wisely in smart factory automation?
Well, maybe you have maybe seen some of the videos where some very major logistic warehouses, which is probably pretty much known. They have their warehouse where the roboters, or like let's say the 4-wheel roboters driving from the one spot to the other spot and moving, transport some stuff. So of course, as you can see here, the magnetics is very needed, specifically when it comes to the communication. So you have like a lot of wireless communication from the one link to the other link as well, and then also inductors, like and also for those type of communications. Where you not only have like wireless but also wired communication, where you have like a type of ecosystem inside the factory, which is AI driven, right? And then for those type of things, you have a lot of, due to the fact that we have to deal with a lot of standards and also safety concerns and safety aspects, a lot of EMI as well. So this is something where Patrik's probably again jumping in and give some.
Yes. And what's really interesting is when we talk about these environments, we are more really in the higher currents. Right. Maybe stuff can go up to 100 amps, 110 amps. So this is getting really big type of chokes and cores. Also, maybe the quantities in that case are not that big. So do you really want to spend time to have to choose your common mode chokes, to have your capacitors and your resistors, and by the way, you can get all that stuff via YAGEO, but maybe it would be so much easier to have just everything in one already. So you just plug it and start to do the filtering. And that's our EMI RFI filters. We do that in single phase, 3 phase, and for the 100 amps or 110 amps, we even do that with 3 phase neutral wires. So really, we have a complete portfolio here to help any design quickness to make things easier for the customer side.
Yeah, specifically when we are talking about AI, there's like, even if we are into this type of smart factories, the data rates that go through, it's like crazy. So this is something what has to be dealt with and also handled with. And of course, I think we have a good solution for this type of applications.
Now, one more aspect, we talk about such high currents that the temperatures might also go pretty high up. So in this case, we have our thermal sensing switches that allow to have some overheat monitoring, make sure things are not getting too hot. Or if it's getting hot, then we have our overheat protection where you can switch off the machines in times, making sure that there is no big issues happening on the side of the robotics, industrial equipment, etc.
Now, AI is not only going to be just in factories and so forth, but actually we all can have AI in our pockets.
Right.
So as it is actually infiltrating the consumer market, so how do magnetics actually scale down for those types of devices?
Well, it needs like really like a compact solution, right? So that means our component needs to be like compact to get like into those type of small devices. So when we are talking about like wireless charging, right? So you have the coils, which is like putting it on the back of the phone, for example, or if you are talking about VAR, for example, or even to console playing where you have like AG45 connectors, which is going through the communication, right? So there is like a lot of applications which can be needed, but at least, as you said, on the smartphone, we have the charging coils. There's also power inductors needed specifically for certain applications for GPUs, for example. And then also the key fact here is of the miniaturization. So as small as we can get, as small as the best performance, obviously, of course. But the fact is, on those type of consumer market, it has to be small and compact.
Smaller is better.
Smaller is better.
And the materials then is going to be important. I mean, if you have a high permeability on the ferrite material, it allows to make things smaller with the same performance. And this is what we are able to do with our ferrites. So for our chokes, for the EMI core, and the EMI issue, we can cover and make it smaller.
Right. And specifically on that, as you said, if you go smaller and the temperature rises, right? So then you have probably a derating on the inductance, so it will then also a loss of performance, at least when it comes to the communication. So there's a lot of type of consideration what has to be also.
And when we talk about communication, you have, especially with the wearables, you want to communicate with the unit, whatever. The flex suppressor in that case can again help on making sure that the communication distances are acceptable or even better than without using the flex suppressor.
Yes.
Now we can see that AI is definitely infiltrating multiple industries and markets. If you had to pick one AI-driven topic for the next 5 years, where would you see the biggest impact magnetics is going to have?
In my opinion, it is like the data centers. So probably because of if we really want to drive AI as finest, so let's say as best as possible, right? We need like to collect and to get like stored type of data what we have. And there's if we get back to the source where data centers are probably, right? So we really need to start from the ground on. And this is, I think, where we probably see that the data centers is one of the important let's say for the next 5 years, where we have all focus on.
I completely agree with Yossuf here. So my only addition would be one of our three here. One is an AI. Who is it? Let's try to find out.
It's not me.
Well, thank you for joining us today, where we dive in and see where magnetics actually play a big role in the AI industry. And with that, I welcome you guys to join us next week again. And until then, keep on asking why.